So temperatures do fluctuate up and down like sine and cosine functions do, although not as predictably. But for this example, we're going to pretend that it fits sine or cosine perfectly. So we've got the temperature going from a low of 45 degrees to a high of 75 degrees. And we might as well find out what's going to be in the middle, because that's going to tell us the vertical shift. So if you average these, it's going to be, add them together, it's going to be 111, with 10 more is 120, 110, and 10 more is 120. Cut that in half is 60. So that means that it goes up by 15 and goes down by 15 from there. So we've actually already got that the amplitude is 15 and the vertical shift is 60, just from not even the first sentence. So we've got the y information that, I better put it over here, that the amplitude is equal to 15 and the vertical shift is the middle number 60. Now we need to know some x information. Like, it's got a high temperature of 75 at 3 p.m. So I'll put this as 1 p.m., 2 p.m., 3 p.m. And then 75 degrees at the highest. And then have it fluctuate. So as the evening comes, it gets colder. Sometime in the middle of the night, it's the coldest. The sun comes up and it gets warmer again the next day. So if it's the next day, then from here to here is going to be 24 hours. Since we're dealing in hours, 3 p.m. to 24 hours later is going to be at 27 p.m. So we've got the period is 24, as well as we've got a phase shift of 3. So we've also got the period equals 24 hours, and the phase shift is 3. From the period, we can find b equals 2 pi divided by the period. So that's going to be pi divided by 12 once it's reduced. And now we have all the information we need to make the function. Y is equal to a vertical shift of 60, and then this looks like cosine, and it's not upside down, so it's plus 15 times cosine. The number in front of the parentheses with x in it is the pi over 12, the b, and a phase shift to the right by 3 means that this should be minus 3. And as always, I would like to graph and make sure that it worked before I go on. So 60 plus 15 cosine pi divided by 12, and then you need more parentheses, x minus 3. And then look at this window, that x goes from 3 to 27, and y goes from 45 to 75. And then take a look at the graph, and it should look like one cycle of cosine. Perfect. And now use that to predict the temperature at 8 p.m. So this was at 3 in the afternoon. So 3 in the afternoon until 8 p.m. So from 3 until 8 p.m. is going to be 5 hours later. So that means this is going to be substitute in an 8 for 5 hours later. So then let x equal 8, and y is going to equal, so 60 plus 15 cosine, the pi divided by 12, and then x, which is an 8, minus 3. Oh, so that right there is saying the 5 hours later. And then evaluate, and it's about 63 degrees, which would be a pretty warm night for Salinas. So it's 63.882 degrees at 8 p.m.